Shchekotov. I am a researcher from Laboratory of Computer-Aided Integration Systems of St. Petersburg Institute for Informatics and Automation of Russian Academy of Sciences. I would like to present you the complex indoor localization technique based on ontology and SLAM method. The problem associated with methods using to determine the location of users of mobile devices within indoors is the time-consuming procedure of setting up and placing equipment, which includes building a map of the room, creating a map of radio signals, and calibrating the radio signal propagation model. In solving this problem, the combined SLAM method and the indoor navigation ontology are proposed. The combined SLAM method includes the phase of forming and training sample, as well as the phase of simultaneous navigation and mapping. The proposed ontology is intended to determine the user's entrance to the room and searching for Wi-Fi access points. And in addition, another events which, for example, affects the radio signal. This ontology is implemented by our ontology language usage, and this ontology is augmented by SWRL rules and our time ontology too. The complexity of this ontology is an next step hard. To determine the user's location, we suggest using the dimension reduction method based on the Gaussian process latent variable model. This method is chosen in particular because Gaussian process allow to find complex patterns in data, and many models have already been built on their basis. So we describe the formulation of the regression problem for the Gaussian process. An important condition will be that there is a sample of data that includes the coordinates of the localization points and the associated values of the signal levels from any access point. So X is a sample of coordinates of localization points, and Y is a set of target variable. Gaussian process evaluates the posterior distribution of functions based on training data. The key idea underlying the Gaussian processes is the requirement of correlation function values at different points, where the covariance between two function values depends on the covariance between the inputs. For example, the dependency can be specified via an arbitrary covariance function or kernel function. The choice of the kernel function is usually left to the user, but the most widely used is the exponent square kernel function. This given distribution takes into account the noise and uncertainty of the model and allows to build a regression in the context of processing the signal levels of Wi-Fi access points. This method involves the formation of training samples for the rooms for which the map is being built directly by users during their movements around the building. The generated samples are used to train the parameters of the car function, which is used to determine the location using GPLVM. To determine the location in the phase of building a training sample, the pedestrian wave reckoning method is used, which is based on the data from the building sensors of the smartphone. This method is augmented by a semi-automatic calibration procedure. This procedure aims to refine the indoor propagation model by several parameters. So this procedure applies for any beacon allocated within the room. So after detecting at least 3 beacons, the multi-rotation procedure started to localize the user. And after this, after forming the training set by PDR and multi-rotation, the SLAM method is used to start the radio map forming and navigation. This scheme presents the phases of GP-LVM based SLAM localization method. So the localization starts when the user enters the room, and this event is detected by smartphone sensors and based on the difference between received signal strength levels. So if the signal is more than in the previous room, so it means that the user entered the new room. After that, by PDM method, we are starting to localize user by building smartphone sensors. And if the user meets some Wi-Fi access point or Bluetooth low energy beacon, then starts the semi-automatic calibration procedure. It means that if the user enters the nearest signal propagation zone, then starts the procedure that calibrates the parameters of signal attenuation model. If user meets at least 3 Wi-Fi access points or Bluetooth low energy beacons, then starts the multi-rotation process, and while this process occurs the data set formation procedure and user's navigation. So in the SLAM phase, when the data set is created, we are starting to the navigation and mapping via GP-LVM method. For this method, the measurement model is developed. So this model aims to save different measurements provided by different methods which are included in this complex SLAM indoor navigation method. So this model includes the information about beacon or Wi-Fi access point, the distance between user and the beacon, angle of user heading, angle of user direction regarding general coordinate system, received signal power, step detection flag, rotation detection flag, and the time of measurement. Moreover, we are distinguishing different cases. For example, when the user enters the room, when user detects Wi-Fi access point or beacon, when user's body is the obstacle, and if user's body is the obstacle but its position is undefined. So if a rotation without step detection is detected and the received signal power is decreased, then there is a signal obstruction by user's body. If no rotation is detected, the received signal power is decreased and steps are still counted, then the user stands in the corner of the room. If no movements is detected and the received signal power is decreased, then somebody stands between the user and the beacon or the access point. So for all these cases, the indoor navigation ontology is developed. So the core concept of this ontology is the measurement, and the measurement representation includes the information about anchor nodes. It means Wi-Fi access point or Bluetooth low energy beacon, the distance, relative angle, absolute angle, received signal power, and time. So all the concepts except of time have appropriate relations, like has distance, has relative angle, and time is presented by time ontology, which is included in the developed indoor navigation ontology. The other concept is the event. The event representation includes such events like navigation within the room, anchor node found, dynamic obstacle detection, the case when user turns back to the anchor node, when rotation is performed, or when step is performed. And calibration starting to for semi-automatic calibration procedure. The Smirnov rules for all these cases can be presented as follows. So we have the concepts and relations between different concepts, and we can, using Smirnov language, determine the rules for all these cases. So this is the rule for the case where user turns back to the access point. The another one is the case when user moving people affect radio signal. So if we have any measurement and there is no step detected, and we have and there is no detected rotation, so and the signal is lower than some constant value, then the dynamic obstacle is met. The another case is when the user enters the room. So this is a simple case when we have detected steps, and the difference between received signal strength is more than some constant, then we are starting the navigation in the room. The proposed combined SLAM method of indoor navigation based on Gaussian process-latent variable model is proposed. This method combines the phase of learning the covariance function parameters and the phase of navigation and mapping without using data about location of Wi-Fi access points and geometry of room map. This method is augmented by pedestrian debris cloning and multi-rotation and semi-automatic calibration procedure. These methods facilitate training set creation and supporting indoor navigation in the phase of training set creation. So to search access points and detect different events, indoor navigation ontology is developed. This ontology is based on our ontology description language and SWRL language. These languages are chosen to represent the positioning and navigation ontology. The developed ontology is described by SROIN description logic with individuals and data. This logic has nx time hard complexity for problems and for problems of concept feasibility and consistency of multiple statements about A box individuals. So that's all. Thank you for attention. If you have any question, you can ask me. Thank you.